In this video, we are going to talk about velocity time graphs or simply VT graphs. There is a small amount of theories when we discuss the velocity times graph. First, I am going to discuss those theories. First, I am going to take a small example. You have two objects moving towards each other and have to sketch velocity time graph of both objects in a same graph. First, you have to choose a direction which where all the vectors are positive. So in this case, I am consider vectors in this directions are positive. So in the velocities, accelerations, displacements in this directions are always positive, and the opposite direction velocities and accelerations are negative values. It's a simple point. So you have to first select a direction. Then there is a two main points or two main data we can obtain from velocity time graphs. Velocity, we can get acceleration from the gradient of the velocity time graph. It is the first. We can take acceleration from the gradient of the graph, and the displacement from the area under the graph. These are the 2 points. So we can show acceleration. First I am going to name the axis. The x-axis we call as time, and the y-axis we call as velocity. So we can show acceleration as this using straight line. This is a constant acceleration. So we can identify acceleration. The straight line always make acute angle with positive directions of x-axis. So this is acute angle which makes positive direction, which make positive directions of x-axis. And we can denote retardation with straight line like this. This is a constant retardation. So it is always make acute angle with negative direction of x-axis. So we can simply identify it. And there is another straight line which denote as a constant velocity which have no gradient. Okay. So I take as theta, the tan value of this acute angle equal to the acceleration, and the tan value of this angle, acute angle, equals to retardation. And the area under the graph always show the displacement which object move. So these are the 2 points we can obtain from the graph. I write this as I take this as alpha, then otherwise it is a problem. Then tan theta equals acceleration, constant acceleration. And tan alpha shows constant retardation. Okay. And the area under the graph shows us displacement. Okay, these are the theories we have to consider. Then we are going to solve a problem using these theories. So I am going to discuss the 2020 advanced level problem. This is the problem in detail. So the three railway stations P, Q and R located in a straight line such that PQ equals 140 kilometers and QR equals A kilometers as shown in the figure. At time 0, a train A starts from rest at P and moves towards Q with constant acceleration F for a half an hour and maintains the velocity it had at e- time t equals half hour for the 3 hours. Then it moves with a constant retardation f and comes to rest at q. At so I am going to first draw the velocity time graph for the train A. So I am consider the direction where p to q. The train moves direction is a positive direction. So I am going to draw VT graph as this. So this denote velocity. In this case, velocity in kilometers per hour and the time is in hours. You have to denote the unit also. It is more clear there. So first, a train started rest and moving with the constant acceleration. So I can show it as this for a half hour. So I am marking this as half hour. This gap equal to the half hour. Right? Then it moves constant velocity 3 hours. Okay. This gap equals to 3 hours. Then constant retardation, it moves and come to the rest at Q station. I mark this velocity as V, and I can mark this as alpha, this as beta. Okay. So I draw the velocity time graph for the train. Then at time t equals 1 hour, another train B start from the rest at R and move towards Q with constant acceleration 2f for t hours and then with the constant retardation f and comes to rest at Q. Both trains come to rest at same instant. So we have to draw the velocity graph for the train B. So it started journey after 1 hour A begin. So train B must start from point like this, right? And the velocity of train B is negative because we consider the direction P to Q is positive, and B train moves opposite direction to the train. So the velocity of train B is negative, and first it moves is acceleration. So the acceleration means the negative velocity must increase. So I show it as this. Negative velocity must increase. Then it has a retardation which equal to f. So the retardation f. So this line also show the retardation f. So then the acute angle must be equal. So I draw a line whose angle equal to beta, and its complete graph as this. I mark this as gamma. This is the maximum velocity. This time is t. They told that with the acceleration it moves time t. Okay, and this velocity I mark as u. This is the velocity time graph we have to do. Then first we have to show that f equals 8. So I am going to find the value for the f. To find the value for the f, I am using the velocity time graph of train name. So here first I am going to find the value for the v in terms of g. So in terms of f, so I use the acceleration term which is equal to tan value of the gradient. Tan alpha equals, here is a right angle triangle. Using right angle triangle, I can write tan alpha as v divided by half. We know that tan value of the acute angle is equal to acceleration, which is equal to f. Then I can write the value of v as f divided by 2. I did cross multiply the values. Then I am going to find the time gap between this point, retardation time. So I use simple t. So there is also right angle triangle. I am using this triangle to find value of t. So we know that tan beta give us the retardation, which equal to f, and v value we got there. So tan value we can write v divided by t. So I can find the t value. I subject t value in here. T value equals v divided by f. We know that v equals to f divided by 2. So f divided by 2f, which means half. So the t value is again half. So I find this value, it is a half. I write it is t value is half. So now we can find the total time train A move. So there is a half hour, 3 hours, and again half hour. Then the total time is 4 hours. So I am going to, and I know the displacement of the train name. In the problem they given that the PQ distance is 140 kilometers, and we know that the area under the graph show us the displacement or a distance between 2 points. So I am going to equal area of this graph to into 140. So this is the actually trapezium. So I can find the area of the trapezium. First I am going to add the length of parallel sides, which is 3 and 4. It becomes 3 plus 4. This is the parallel side. This is a one parallel side, and this is a one parallel side. So values are 3 plus 4. We should divide it by 2 and multiply by perpendicular distance. Perpendicular distance is v. This equals to 140. We know that 4 plus 3 is 7 divided by 2. We get value for the v as f divided by 2 equals 140. Now I can divide equation by 7. 1 20, and there is a 2 into 2 4, cross multiply, then f equals to 20 into 4 means 8. So we get the value for the f simply as this. Then we have to show the find the values of t and a. So next I am going to find value of t. uh, we know that the second train begin its journey at after 1 hour, then this point denote 1 hour, and the total time is 4. So this gap shows us the 1 hour. Then other gap, this triangle side of this triangle shows the 3 hours, and we get this gap is a capital T. Then I can write this gap as 3 minus T, because this side must get the value equal to the value 3. So I am going to find the value for this T. Okay, first I am going to use this triangle. So using that triangle I can write tan value, right? Tan gamma equals, we know that tan value equals to the acceleration 2f, and I can write tan value using triangle, which equals to u divided by t. Okay, then I can get a value for the u as 2f into capital T. Then I am using another triangle, then tan beta. In tan beta show us the retardation. Then retardation, we know that f equals, we can write tan value for the triangle using triangle, which equals to u divided by 3 minus t. This gives us value for the u as f into 3 minus t. Then we have get the value 2 equation for the u. So we can equal this equation, because the two these two equations we get for the u. So by equaling this equation I can obtain this 2ft equals f into 3 minus t. Then I can divide by f, then expand the 2t 3 minus t, then minus t come here, 3t equals 3, which means we can divide the equation by 3 and obtain value for the t as 1. Then t is 1 hour. I find the value for the t. And then we have to find the value for the a. A means distance between point Q and R, or a station Q and R. So obviously we know that we can get that value from the area of the triangle, which is the VT graph of train B. So I'm going to find it here. So we have to find the u value, no problem. So I'm going to erase these things. So using the triangle I can find its area, and it equals to it. So I'm going to find the area of the triangle, which we can write as this, half into base. Base is, we know that the value it is 3 hours, this triangle I am considering 3 hours, and the perpendicular distance equal to u, which equals to e. Right. We can get value for the u using this. I am using this one. 2 times we get value for the f as 80 and t as 1, which give us 2 into 80 means 160. I am going to substitute it here. Half into 3 into 160. I can denote to divide 80 equals 80 into 3 is 240 kilometers equal to. So we solve the problem completely. So this is the whole theories about VT graph. You have to take the tan value of tan value of the gradient. Gradient equals tan value of the acute angle. Retardations also the. So I explained the directions with directions, and we have to consider the areas. Very simple. So using these things, we can simply solve any VT graph problem. But you have to understand the given problem properly. Otherwise, you can't draw the VT graph accurately. If the VT graph wrong, the problem gonna be the mess. So we have to sketch right VT graph, then we can solve the problem very easily using tan values and the areas. So in next video, I am going to solve another VT graph problem. So